For this video, I will discuss understanding hypothesis testing, a topic for senior high school statistics and probability. Hypothesis testing is a statistical method used in making statistical decisions using experimental data. It is a process of gathering evidences to either accept or reject a claim, a guess, or an assumption known as hypothesis. This video focuses on evaluation of a claim about parameter or a distribution which is done through a statistical test of hypothesis. Let's have first this definition. Hypothesis is considered as an educated guess which provides proposed outcomes based on experience and theoretical knowledge which is likely to be correct. It is an idea or explanation for something that is based on known facts but has not yet proven. Here are some examples of hypotheses. Number 1, drinking milk before going to bed will make you sleep better. This statement is a hypothesis because this statement needs to be proven by a series of investigations to prove that drinking milk will make us a better sleep. And it is the same for the two other examples. Number 2, hand sanitizer A is better than hand sanitizer B in terms of germ-killing effects. Number 3, there is no significant relationship between the intellectual quotient and emotional quotient of GAS students. Again, they are hypotheses just because they are a statement need to be proven first before they will be accepted. Next are examples of not hypotheses. Number 1, Asia is the largest continent in the world in terms of area. We all know it is not a hypothesis just because it is a fact. Number 2, the sum of the angles of any triangle is 180 degrees. Also, this is not hypothesis. This statement does not need to be proven because it is a postulate. Number 3, the boiling point of water is 100 degrees Celsius. Again, this is not a hypothesis. This is a scientific fact. Let's have this another definition. Statistical hypothesis is a claim or a conjecture that may either true or false. The claim is usually expressed in terms of the value of parameter or the distribution of the population. We have two kinds of statistical hypothesis. Number 1 is the null hypothesis. It is denoted by the symbol H sub O. It's a claim that denotes absence, such as absence of difference, absence of relationship, or equality to a certain value. It is usually comes with equal, less than or equal to, greater than or equal to when written in symbol. Number 2 is the alternative hypothesis. It is denoted by the symbol H sub A. Is a claim that denotes presence, such as presence of difference, presence of relationship, or equality to a certain value. It usually comes with a symbol not equal, less than, or greater than when written in symbol. Let's proceed on the steps of formulating hypothesis. Number 1, identify the claim. It will answer the question, does it denotes absence or it states equality to a certain value? Step 2, identify the parameter used in the claim. It will answer on the question, does it talk about population average or a proportion of a population? Step 3, represent the parameter by a symbol. Mu for population average and P for population proportion. Number 4, be sure that null and alternative hypotheses are complementary and not overlap. Letter A, H sub O, the parameter is equal value versus H sub A, the parameter is not equal value. Letter B, H sub O, the parameter is equal value versus H sub A, the parameter is less than value. Letter C, H sub O, the parameter equals value versus H sub A, the parameter is greater value. Letter D, H sub O, the parameter is less than or equal to value versus H sub A, the parameter is greater value. And letter D, H sub O, the parameter is greater than or equal value versus H sub A, the parameter is less than value. Let's take this example 1 in formulating hypothesis. A manufacturer of IT gadgets recently announced that they had developed a new battery for a tablet PC and claim that it has an average life of at least 12 hours. Would you buy the battery? For step 1, the claim is the average life of a newly developed battery for tablet PC is at least 12 hours. Step 2, the parameter is the average life of a newly developed battery for tablet PC. Step 3, the symbol to use for parameter is mu just because the parameter represents a population. Step 4 is identifying the null and alternative hypothesis. Since the statement showing that h sub o, the parameter, is greater than or equal to the value versus h sub a, the parameter, is less than the value, in words, h sub o or the null hypothesis will be the average life of a newly battery for tablet PC is at least 12 hours. And h sub a or the alternative hypothesis will be the average life of a newly battery for tablet PC is less than 12 hours. In symbol, h sub o, mu is greater than or equal to 12, h sub a, mu is less than 12. Example 2, a student researcher wants to test his assumption that 60% of the senior high school students who enrolled in academic track wanted to become a teacher. He collected samples randomly and found out that 30 out of 175 students are planning to become a teacher. State the null and alternative hypothesis. Step 1, the claim is 60% of the senior high school students who enrolled in academic track wanted to become a teacher. Step 2, the parameter is 60% of the senior high school students who enrolled in the academic track. Remember that the value 60% refers to the proportion of the population. Step 3, the symbol to use for parameter is P. Like what I said before, the value 60% refers to the proportion of the population. Step 4, identifying the null and alternative hypothesis. Since the statement showing that h sub o, the parameter, equals the value versus h sub a, the parameter, is not equal to the value, in words, h sub o or the null hypothesis will be the proportion of senior high school students enrolled in the academic track who wanted to become a teacher is equal to 60. H sub a or the alternative hypothesis will be the proportion of senior high school students enrolled in the academic track who wanted to become a teacher is not equal to 60. In symbol, h sub o, p is equal to 0.60 and h sub a, p is not equal to 0.60. Let's take another definition for further discussion. Test of hypothesis is a procedure based on a random sample of observations with a given level of probability of committing error in making the decision, whether the hypothesis is true or false. The decision of accepting or rejecting a statement or claim is coupled with consequences. To continue, we will give possible consequences on the given statement or a claim. What are the consequences if the government pronounced an El Niño phenomenon? In this question, the claim or the statement is the government pronounced an El Niño phenomenon. The possible consequences are import rice in anticipation to rice shortage or buy materials for water shortage like water pumps and others. 3. Use a variety of rice that could resist drought and others. Again, these are possible consequences to accept the statement. And the possible consequences to reject the statements are people are not ready for the rice and water shortage. 2. Farmers will experience losses in production. 3. We do not do anything and others. And these are the summary in tabulated form on accepting and rejecting the hypothesis. The first column are the possible actions to the hypothesis. In the second column are the possible consequences if the hypothesis is true. And the third column are the two possible actions or consequences when the hypothesis is false. Outcome number 1. If the null hypothesis is true and not rejected, it means accepted. The decision is correct, it means no error committed. Outcome number 2. If the null hypothesis is true and rejected, the decision is incorrect, type 1 error is committed. Outcome number 3. If the null hypothesis is false and rejected, the decision is correct, no error is committed. Outcome number 4. If the null hypothesis is false and accepted, the decision is incorrect, type 2 error is committed. Again, please remember this. As mentioned earlier, every action corresponds with consequences. When an error is committed, consequences happen too. In statistics, the chance of committing an error is measured, and these measurements serve as the basis in making a decision. Let us clarify that on this example 1. A manufacturer of IT gadgets recently announced that they had developed a new battery for a tablet PC and claimed that it has an average life of at least 12 hours. Would you buy the battery? And these are the explanations of committing errors. Type 1 error is committed if you decide not to buy the battery. If you did not buy the battery, the possible consequence will be you will lose the opportunity to have a battery that would last for at least 12 hours. Type 2 error is committed when you buy the battery and found out that the battery's average life will be less than 12 hours. The consequence is you wasted your money in buying the battery. Example number 2. A teenager wants to lose weight. In contemplating on a diet, she read about social media. She wanted to adopt the diet, but unfortunately, it requires buying nutritious, low calories, yet expensive food. Help her to decide. Continue. Type 1 error is committed if the teenager followed the diet. Why it is an error? Just because the teenager instantly followed the diet even the product is not yet proven. By that, the possible consequence will be she spent unnecessary for a diet that did not help her reduce weight. Type 2 error is committed if the teenager did not follow the diet. Its consequence, the teenager lost the opportunity to attain her goal of weight reduction. Again, I hope this video helps you in your study. To help others, please subscribe, like, and share.